Hello, we are Group 5. We have Ari, Gabby, Evan, and I am Nick Spidell. And this is our final presentation for Management of Technology. And this is the analysis of the electric propeller plane market, specifically in pilot training. All right, now for a brief introduction of the aviation industry. This industry is massive and it's affected all of our lives, guaranteed. It's got travel to consumer goods. Most everything's been on a plane at one point or another. And now with this, it's had a very long history of innovation, from the Wright brothers' first flight in 1903 to this first supersonic flight in 1947. Now, with industries of this size, there tends to be more just natural issues and natural demands. And while this sometimes can hurt one market, an issue can hurt a market, might create opportunities in another one. Right now, what's going on is a massive pilot shortage. There's actually a study conducted by a flight school that in the next 20 years, there's going to be another 120,000 US pilots, not global, just US. Now, while this is a setback for commercial airlines who are struggling to find pilots or maybe to help keep pilots, they're having to pay them more. It's a big opportunity in the pilot training market, and that's what we're going to get into. Now, for a quick background on pilot training and why there is a pilot shortage, the reason is cost and time. The average cost to become a commercial pilot, so we're talking from never flying a plane to being able to fly regionally or nationally, be able to get that commercial pilot license. Costs on average is over $85,000. Some reports even say up to $135,000. This is a massive expense that scholarships are, I would say, like less frequent than regular schooling, regular universities. And this is also a very long path. It takes many years. There is a list of certifications before you can actually fly commercially. And one of these is just simply you need 1,500 flight hours in order to become a commercial pilot. That takes a lot of time. That's why it's expensive. Planes are not cheap to run. And there are different roads. Some people can get on with a regional or start doing flight lessons to help pay this off. But no matter what, it's a long road and it's expensive. Now, while there are different routes to do this, the first step for anybody is the private pilot's license. This is on average still $14,000 to $22,000. That's out of the person's pocket. The reason it's so expensive is flight time's expensive. It's expensive to maintain the planes, to pay the instructor, and so to help alleviate this pilot shortage, get more people through the program, there's one of two options. You can either shorten the time, which that's not a great idea because we don't want less experienced pilots, or you can lessen the cost. Now, the answer for this, lessen the cost, and this can be done using the electric propeller planes, and this is the basis of our project. All right, now that we know a little bit about pilot training in the aviation industry, let's get to our critical issue, what this project is about. And we know that the electric planes can help in the pilot training market. So, what we're analyzing there is what is the best strategy to gain a competitive advantage in the electric propeller plane market. We're strictly looking at the electric propeller planes, and there are two main routes companies have gone. And it is the most advanced technology, or do they have the best marketing and production ability? What's the difference here? Advanced technology, we're talking the most powerful motor. It's got the best noise reduction. All of the pros of why electric can overtake this market, they do better at. It's got the farthest range, the shortest charge time. Very good benefits here into using the electric planes. Or the other side, is it the marketing and production ability? Are they able to be the fastest to get certified in the FAA? Do they have the best strategy to scale production? Do they have existing facilities to be able to start producing planes? Existing complementary assets? Do they already have ties to get charging stations installed into these flight schools? and the largest marketing network, do they already have a big backlog of pre-orders? Do they already have their foot in the door in this industry that will help them be able to take the business off the ground and ultimately run with it, even if they don't have the best electric planes?
This is just a quick overview of the industry analysis before getting into the details. Right now, electric trainer aircraft is still pretty early, but there's a ton of long-term potential, especially with everything moving toward more sustainable aviation. The big thing, though, is that it's not easy to break into. Certification takes a long time, it's expensive, and there's a lot of testing involved. So even if a company has good technology, that doesn't mean they can actually get into the market. Adoption is mostly being driven by lower operating costs and sustainability, which is why flight schools are interested. And the main idea here is that success is really about execution and not just technology. This slide breaks down the competitive structure using Porter's five forces. Rivalry is moderate to high because companies are competing for a small group of early adopters and credibility matters more than price right now. The threat of new entrants is low because it's expensive and it takes a long time to get through certification, which limits who can actually enter the market. Supplier power is medium to high since companies rely heavily on specialized components like batteries, motors, and avionics. Buyer power is moderate but increasing since flight schools care a lot about cost and reliability and will have more options as more aircraft get certified. And finally, substitutes are high since traditional gas aircraft and simulators are still widely used today. Overall, it's a pretty challenging industry early on. This slide focuses on where firms actually create and capture value in this industry. The main idea is that it's not just about having the best propulsion technology. That's important, but it's not enough on its own. The companies that are going to succeed are the ones that can combine multiple things like getting certified, scaling production, providing maintenance and support, and having strong distribution or network access. So really, it's about building a full system around the aircraft, not just the aircraft itself. That's why companies that can actually deliver a complete, reliable product to customers are in a much stronger position than those that just have promising technology. This slide shows where the industry is in terms of growth using an S-curve. Right now, the industry is still in the early stage, moving from certification into initial adoption. So progress is happening, but it's still relatively slow. The main drivers pushing growth are things like battery performance, certification progress, and operating cost savings for flight schools. But there are also limits, especially with current battery technology, which restricts range and endurance. That's why we show a potential second S-curve. If battery technology improves, it could unlock another phase of growth and make these aircraft more widely viable. This slide shows the overall value chain in the industry. It starts with inputs like batteries and components, then moves through design, certification, production, and finally support. The key point is that most of the value is actually captured in certification, system integration, and after-sales support. Those are the hardest parts to replicate and the most critical for customers, especially flight schools that depend on reliability and availability. Value in this industry does not come from building the aircraft, it comes from executing across the entire system.
This market is driven primarily by a global pilot shortage, which has become a major issue across the aviation industry. As air travel continues to grow worldwide, airlines are expanding routes and increasing the number of flights, which directly increases the demand for trained pilots. However, the supply of new pilots has not kept up with this demand, creating a gap that training programs need to fill. At the same time, the current fleet used for pilot training is extremely old, with an average age of over 45 years. That means many of the aircraft currently being used are not only outdated, but also more expensive to operate and maintain. This creates an additional challenge because flight schools need reliable aircraft to train students efficiently. Another major issue in this market is the high cost of becoming a pilot. The total cost can easily exceed $100,000, which makes it difficult for many people to enter the profession. Because of this, costs become one of the biggest limiting factors in how quickly new pilots can be trained. So overall, we have a situation where demand for pilots is increasing, but training capacity is constricted by high costs and aging equipment. This is what creates a strong opportunity for new technologies to improve the system. Market size and growth. This is a large growing market. Estimates suggest that around 25,000 new training aircraft will be needed over the next decade, which represents a total addressable market of over $5 billion per year. What's important about this is not just the size, but what's driving the growth. A big factor is the expansion of flight schools and university aviation programs, which are increasing capacity to meet rising demand for pilots. In addition, many airlines are now investing in their own training academies to secure a more reliable pipeline of pilots. Another key point is that much of the demand isn't just for new growth, it's also for replacing older aircraft. Since the current fleet is so outdated, a large portion of this market comes from necessary fleet renewal rather than optional upgrades. So overall, the market represents both a replacement opportunity and a growth opportunity, which makes it especially attractive for new technologies like electric aircraft. One of the biggest challenges in this market is costs. Becoming a commercial pilot can cost anywhere from about $85,000 to $130,000, depending on the training path and location. Even the very first step in the process, earning a private pilot license, can cost up to $22,000. These costs add up quickly because pilot training requires a large number of flight hours, and every hour in the air is expensive. The main drivers of these costs are aircraft operating expenses, especially fuel, maintenance, and instructor time. This becomes a major barrier because it limits how many people can realistically pursue a career as a pilot. It also slows down the rate at which new pilots can enter the workforce, which directly contributes to the ongoing pilot shortage. So when we look at this market, cost isn't just a minor issue, it's really the root problem. And that's exactly what new technologies like electric aircraft are trying to solve by reducing the cost per flight hour. Electric aircraft directly addresses the cost problem we just discussed. One of their biggest advantages is the reduction in operating costs. Compared to traditional gasoline-powered training aircraft, electric aircraft can reduce operating costs by up to 78%, mainly because they eliminate fuel expenses and have much simpler propulsion systems. They also have significantly lower maintenance requirements. Electric motors have far fewer moving parts than internal combustion engines, which reduces wear and tear, lowers maintenance costs, and increases overall aircraft reliability and uptime. In addition to the economic benefits, electric aircraft also produce zero direct emissions and generate much less noise. This can be especially important for flight schools operating near populated areas where noise restrictions can limit training hours. Another key point is that pilot training missions are typically short and repetitive, often lasting 1 to 2 hours and involving frequent takeoffs and landings. This type of mission profile is actually ideal for electric aircraft, even with its current battery limitations, because range is less of a consistent constraint compared to other types of aviation. So overall, electric aircraft are not just a new technology, they are particularly well suited to this specific market, both economically and operationally. The primary customers in this market are organizations involved in pilot training, including flight schools, university aviation programs, airline-sponsored training academies, and aero clubs. These groups are responsible for training new pilots at different stages, from beginner licenses all the way to commercial certification. What's important to understand is that these customers operate more like businesses than individual consumers. Their goal is to train as many students as possible while keeping costs low and maintaining high safety standards. Because of this, their purchasing decisions are very focused on economics and efficiency. There are a few key factors they care about most. First is operating costs, since fuel and maintenance directly impact how expensive it is to run each training flight. Second is aircraft uptime, meaning how often the plane is available to fly. If an aircraft is down for maintenance, that directly reduces revenue for the school. They also prioritize reliability and safety. Since the training environments require consistent and predictable aircraft performance, finally, they care about or in service, such as access to maintenance networks and replacement parts. So overall, these customers are not just looking for the most advanced technology. They are looking for solutions that are cost-effective, reliable, and easy to integrate into their existing training operations. The competitive landscape in this market includes companies like Pipistrel, Buy Aerospace, Aura Aero, and H55. Among these, Pipistrel currently has a first-mover advantage because it already has a certified electric training aircraft in operation, while most other companies are still in the certification or development stage. However, competition in this space isn't just about having better technology. There are several major barriers that companies need to overcome. The biggest is certification, which is a long and complex regulatory process. In addition, there are challenges related to charging infrastructure, battery performance, and gaining customer trust in a new technology. Because of these barriers, success in this market depends not just on innovation, but on the ability to execute, scale, and deliver a reliable product. Overall, this is a large and growing market with strong demand driven by the pilot shortage and the need to replace aging aircraft. Electric aircraft presents a clear opportunity by significantly reducing operating costs and improving efficiency. However, adoption is not guaranteed. Success in this market will depend not just on the technology itself, but on the ability to achieve certification, scale production, and provide reliable support to customers.
Now we'll look at the firm analysis. To give you a roadmap of what we're going to cover, we're looking at four main areas. First is the innovation pivot, or how companies are shifting away from legacy gas-powered builds and moving toward cleaner, purpose-built designs. Second, we'll look at collaborative models and how these firms are leveraging strategic alliances to handle the high cost of tech development. Third, we'll discuss entry dynamics, specifically the high-stakes certification race between the top players. And finally, we'll touch on systems design, where firms are developing modular airframes to make it easier to scale up production. Let's dive into the strategy behind the innovation first. When we look at innovation strategy, the biggest question a firm faces is whether to do a retrofit or a clean sheet design. A great example of this is Buy Aerospace. They actually started out by trying to do a 172 retrofit, which is basically taking an old Cessna and swapping the engine, but they eventually abandoned the 172 retrofit to build a clean sheet airframe instead. They made this choice because they were prioritizing high efficiency over the low cost of retrofitting. Even though retrofitting is cheaper and faster, a gas airframe is heavy and not aerodynamic enough for batteries. By going with a clean sheet design, they could use purpose-built composites that eliminate those legacy weight issues. This allowed them to maximize the plane's range, which is the number one thing flight schools care about. It's a classic case of a firm choosing radical innovation over incremental changes to gain a long-term performance lead. Building a new type of aircraft is inherently expensive, so these firms aren't trying to do it all alone. Instead, they use partnerships with Safran and H55 to outsource R&D to specialists. Safran handles the electric motors, and H55 handles the battery management. This is a smart move because it allows the aircraft company to focus on the plane itself, while the experts handle the high-tech propulsion systems. By relying on these specialized aerospace suppliers, the firms can minimize their fixed capital, meaning they don't have to build massive, expensive factories for every single component. But it's not just about the manufacturing, it's also about the market. These firms are forming alliances with global flight academies to provide a steady stream of customers. These academies essentially act as launch partners, giving the firms a guaranteed order book before the planes are even finished. Timing is everything in this market, and we're seeing two very different strategies play out right now. On one hand, you have Pipistrel, who secured initial market share by certifying the world's first electric trainer. They were the first mover, and that allowed them to get their planes into flight schools while everyone else was still in the testing phase. On the other hand, Buy Aerospace is targeting the more rigorous FAA Part 23 certification for broader U.S. adoption. While they aren't first, their goal is to have a more commercial-ready plane for the massive U.S. market. Regardless of the timing, the ultimate success for both firms is dictated by their ability to navigate FAA safety issue papers. This is a long, difficult process where the government scrutinizes every wire and battery cell. Being the best at engineering is one thing, but being the best at managing the certification process is what actually gets these planes in the air. Finally, we need to look at how these firms actually plan to scale up their production. Most of them are using a modular design approach, where using common parts between models reduces manufacturing costs. For instance, the two-seat trainer and the four-seat passenger version might share the same wings or cockpit, which makes the factory much more efficient. They are also using rigorous NPD or new product development staging to transition from the prototype phase to a full assembly line. This helps them catch errors early before they spend millions on mass production. Interestingly, while they outsource some parts, we see a lot of closed propulsion integration to maintain total control over the system. They want to make sure the motor, battery, and software talk to each other perfectly. By keeping that part closed and proprietary, they ensure safety and make it harder for competitors to copy their specific performance secrets. The roadmap for the next few years comes down to three key steps. First, companies have to find the right balance between in-house production and third-party contracts. They need to scale up without going bankrupt from building too many factories. Second, they need to be leading the charge on universal charging networks. Just like electric cars, these planes won't be useful unless every airport has the same plug. And finally, the ultimate goal is to expand into the 4 to 9 seat plane market. The two-seat trainers are just the beginning. The real future is using this technology to move larger groups of people and cargo between cities. If they can hit these three marks, they'll move from a niche flight school product to a major player in the broader aviation industry.
Everything up, electric trainer aircraft are a really strong fit for the market, mainly because they can lower operating costs and support sustainability goals. There are still some major barriers, especially certification, battery limitations, infrastructure, and just building customer trust. Because of that, the biggest takeaway from our analysis is that competitive advantage isn't going to come from just having the best technology. It's really about execution. The firms that are most likely to succeed are the ones that can get certified quickly, build strong partnerships with flight schools, provide solid support networks, and actually scale production and charging infrastructure. Overall, it is really about combining good technology and the ability to deliver it.